I'm good. How are you, doctor?
I'm fine. So how's the rain in your place?
Not too bad. Some streets are flooded, but not all of them.
Mm-hmm. Okay, Miss, stay safe then. Hello, Sultan. Hello, Abu Zaid. Hello, Ahmed. Okay, Miss. Please let me know if all of us are able to see the screen.
Yes, doctor.
Okay, Miss. Miss, already last lecture we started with chapter 6, and we said that our main objective is to solve a linear differential equation using series solution. What we did last lecture is we record together what's meant by power series, center at 0 or center at A, and we said that in our course we are just interested when it's centered at 0. Then we talked about the process of adding two power series together or more. Then we differentiated between ordinary and singular points, and we started with the method of power series solution, but we did not solve anything on it. So this is what we mean by power series. It has this shape. It looks like a polynomial, but without a certain degree. It means that n tends to infinity. And we said that in order to add two power series, first we should making them having the same power and then same starting value. Then we introduced what's meant by ordinary and singular points, and we said that we care about P of x and Q of x to be analytic at this point. It means that differentiable at this point and in a neighborhood of it. We gave also some examples. For example, if we have this one, when P, it will be 2 over x squared minus 1, and Q is 6 over x squared minus 1. So our problem is when x squared minus 1 is equal to 0. So these will be the singular points when x equal plus or minus 1. Also, we said that if y is written as a series, we can find y prime and y double prime. If y, we are starting at n equals 0, then y prime n equal 1 and y double prime n equal 2. Any questions about these ones, Miss? Okay, so what we will do today is that we need to solve a differential equation. Here we have an example. Our aim is to solve y prime plus 2xy equal to 0. So our aim is to solve this one. We need to use the series solution. So we started as y equal. This one we started with at last lecture. Sigma Cn xn and y prime and Cn xn minus 1. So here we used xn. The derivative of it is n x n minus 1. And of course, we'd not start it at n equals 0. And suppose that you wanted to start it at n equals 0, it will be 0 because we have here 0 times something is 0. So immediately we can start it at 1. Then what's our next step? Substitute in the differential equation. So instead of y prime, we need to put its value. And instead of y, we need to put its value. So this is y prime. And so we will get y prime sigma n equals 0. Y prime is n equal 1 to infinity n Cn x n minus 1 plus 2 into sigma from 0 to infinity x Cn, or x is outside as well. We can write it. So here we have 2x. And here sigma Cn xn equals 0. This step, are we okay with it, Miss?
Yes.
Okay. Miss, everything that is outside, including the constant, should be inside. So we need to put this 2x inside. What will we get, miss? Sigma 0 to infinity, 2 is inside, 2 times Cn, and x times xn, it will be what, miss?
xn plus 2.
X times xn, xn plus 1.
I thought it's 2x. Okay.
Okay, miss. Now, where's our problem here? We have here a power, n minus 1, and here what do we have? N plus 1, right? So the first one, what should we use for it? N minus 1 equal
k.
m.
أيوه. It's
So
same as
n
k,
is,
right?
yes. So this one that is here, it will be sigma n, instead of it, we will put n plus 1, c m plus 1, x m, which is where? Here. Now, what do we need to find? The starting value. N starts from 1 to infinity. M is equal to what, miss? N minus 1. So what will we get the starting value of M?
0.
0. And infinity minus 1, is it changed?
No.
Now for the second one, what do we need to put? Instead of n, we will put m minus 1. Now, we are saying that m is equal n plus 1. And n starts at 0. It means that m equals 0 plus 1, which is 1. So we will start here at 1. Is it clear, miss?
Yes.
Okay, miss. Now, both of them, they have the same power, but where's our problem? The same power is solved.
Different starting points.
Okay. Now, this one is m equals 0. So, it is at 0 plus starting from 1, right? Why did we put it as at 0 and starting from 1? Because the second one, it starts at what? Miss, the second series, it starts at what?
You want all of them to start at 1.
Exactly. Okay, miss, what will we get? At m equals 0, substitute 0 plus 1, c1 x power 0. So what will we get? c1. So we will get c1. This one, when we evaluated it at m equal to 0. And then from 1 to infinity, this 2, as we said, we can put it inside. Do they have now the same power and same starting value?
Yes.
Okay, so C1, we will keep it alone. Sigma x power m. From the first series, we have m plus 1, cm plus 1. And from the second series, what do we have? 2 cm minus 1. Do we have any questions regarding this one, miss?
No.
Okay, miss. Now, what's the next step? When we reach this one, miss. We got this series equal to 0. What does this one mean? Miss, so basically here what we got is C1 plus sigma x power m equals 0. What do we mean by when we say a polynomial is equal to 0? The coefficients, they should be what?
Zeros.
Zeros. What are our coefficients here? This is coefficient, and here we have the other coefficients, right? So each of these coefficients, they should be what, miss?
0.
A 0. So the first coefficient, we got from it C1 equal to 0. The second coefficient, we would write it m plus 1, cm plus 1 plus 2, cm minus 1 equal to 0. Now, the recurrence relation, we get it from the m's. Which one is larger, m plus 1 or m minus 1?
Plus 1.
So we will write Cm plus 1 in terms of Cm minus 1. What will we get, miss? We will get this one. And this one, we call it recurrence relation.
Can you repeat the last step?
Okay, when you reach this one, when you reach this one, miss, you need to write the largest in terms of the smallest. So bring Cm minus 1 to the other side. What will you get?
Oh, okay, I get it.
Okay, so the recurrence relation that we got is Cm plus 1 is equal to minus 2 over m plus 1 C m minus 1, right, miss? And also, what did we get? We got C1 equal to 0. We will solve now this recurrence relation. These two ones, they are considered now as recurrence relation. We need to take values for m's. Already we have C1. So if I substituted m equals 0, it doesn't make sense because already C1 is given. So we will make this table, miss. We will take values for m. So can I take m equals 0? Suppose that you want to take m equals 0, you will get c minus 1. We do not have c minus 1. So we'll start with m equal 1.
2.
Then
2.
m equal 2, m equal 3, m equal 4, and m equal 5. At m equal 1, miss, we will substitute C1 plus 1 is equal to what? C2, right? M equal 1, miss, substitute here.
Yeah, C2.
Okay, and substitute here, what will we get? Minus 2 over 2 C0, which is minus C0. Is it okay, miss?
Yes.
Now, at m equal 2, what will we get? C3 equal minus 2 over 3 C2 minus 1, which is C1. What's C1, miss?
C1 is 0.
So we'll put 0. 0 times any real number is 0. Now, at m equal 3, miss, what will we get? C4, 3 plus 1 is 4, minus 2 over 4, C3 minus 1, which is C2. So we will get negative half, miss, C2 is equal to what?
Negative C0.
Okay, so negative times negative, we will get?
Positive.
So what do you mean by this one, miss? It means that we need to write all the CIs in terms of C0. At m equal 4, what will happen, miss? C4 plus 1 is C5 equal negative 2 over 5. C5 minus C4 minus 1 is 3. And what's C3?
0.
So we will get the answer of this one as 0. Now, C6 here is equal negative 2 over 6 C4. And what's C4, miss?
Half C0.
C4, miss?
Half C0.
Half C0. So we will write it. Okay, miss?
Yes, but how many M's do we need?
Miss, for example, here, if we have first order, we got here 3 non-zeros, they are enough. The idea is in how many non-zeros we can find.
Okay.
Okay. So again, this is the recurrence relation, and already C01 was given as 0. We took some values, we found them, all of them in terms of C0. Now, what's the next step? Y is equal to C0 plus C1x plus C2x squared. Isn't this the solution? C3x3 plus C4x4 plus C5x5 plus C6x6 plus, we should put these dots, okay, miss? Now C1 is what? 0, right?
Yes.
C1, miss, 0. And what else equal to 0? C3, C5, right?
C5.
So C3
C5.
is 0,
Yes.
and C5 is 0. What are we left with? C0. Okay. What's C2? C0 over 2, right, miss?
Yes.
C2 is minus C0.
Again.
C2, from here, it's minus C0. It's the first one. Okay. Now, plus X4. C4 is what, miss?
Half C0.
Okay, we will write here half C0 plus the X6. C6, what was it? Minus C0 over 6 plus C. If you look here at the solution, miss, it's written in terms of what? C0.
C0.
So we can take C0 in common. What are we left with? 1 minus x squared plus x4 over 2 minus x6 over 6. And what should we put? Plus dots. If we don't put the plus dots, it means that it's wrong, as if you are saying this polynomial is a solution, but in reality, it's not the polynomial, the solution, it's the series. So we have other terms, but we cannot find all of them. With the first example, it was just as illustration. The second example, we'll go through it in details, but the main thing is to understand first, how do we start? We substitute y, we substitute y prime, we substitute y double prime if we have it. And then we will simplify in the way that how we add two series by making the same power and same starting value, then getting the recurrence relation, and then getting values for m. Remember, miss, if it's a first order differential equation, how many solutions should we get? How many independent solutions should we get, miss? 1. So how many in terms of what we will find it? In terms of one solution, in terms of how many C's?
1C.
When C0. Now, if we have second order, what do you think? How many series solutions should we get?
2.
How many independent solutions should we get if we have it second order?
2.
2. So in terms of C0 and C1, it will be. Okay, miss? Okay, miss. Let's look at this example now. What's the order of?
2. Second order.
So we are expecting to get second order two series solution. It means that in the recurrence relation, we'll find everything in terms of C0 and C1, right, miss? But first, in order to use the series solution, what do you think? X equals 0 is ordinary or singular? What's P of X, miss? P of X is 0 and Q of X is X.
Both of them are
These are
differentiable.
polynomials implies analytic. At 0 implies that what will we get this one as? Ordinary point. Okay, miss?
Okay.
Is it clear?
Yes.
Do we still, okay. Do we still remember the ordinary point? No, we have the right, because it's ordinary, to use the series solution. Summation n equals 0 to infinity Cn x n. Now, no need to find here y double prime if already you memorized them. Y prime is not there, so just we need y double prime. And we start it from 2 to infinity n into n minus 1 Cn x n minus 2. Right, miss? Do we have any questions, miss? Do we have any questions?
No.
What was the equation? Y double prime plus xy equals 0. So let's write it. Y double prime is sigma from n equal 2 to infinity n into n minus 1 Cn x n minus 2 plus xy sigma from 0 to infinity. Xy, it means that Cn x times x power n, xn plus 1 equal to 0. So here, what did we make? We substitute in the ODE and we got this one. Is it clear, miss? Is it
Yes.
clear?
It is.
Miss, by the way, the series today we will finish it. So please, if there is a problem, let me know, because next week hopefully we'll start with Laplace transform. So the method of series solution, because we are just considering the ordinary point, it needs just with us 2 lectures. Plus, it's something that it's just a process, miss. If you look here, we are not integrating, we are not differentiating that things that they are difficult. These are just only steps. Each step, like we need to understand the algorithm of it. So the first one, what's the series? N minus 2 here and plus 1. Both of them, they should be what? The same. So in the first series, this one we will consider it as M. Miss, if you want to consider it as K, I don't mind. What do you prefer to use, M or K?
K is better.
Okay. So we will put this one as K. And this one here, we will put it also as K. We will work with each series alone. So the first thing, this is series number 1. Let's write it. It's sigma 2 to infinity n minus 1 Cn x n minus 2. We said that we want our K to be n minus 2. So when we have sigma, miss, 2 minus 2, it means that it's what? 0. And infinity, is it affected? N is equal to what here, miss? K plus 2. So instead of n, we will put K plus 2. Instead of n minus 1, K plus 1, C, K plus 2. And here, what do we have? Xk. Is it clear, miss?
Yes.
And K starts at 2, N starts at 2, K equal N minus 2, so K starts at 0. Does it make sense? Please, miss, if you want to take notes, take your notes before we move to the second series.
You can move on, Doctor. It's clear.
Okay, so now let's go back to the second series. Second series is sigma Cn Xn plus 1. So we will write here, this is the second series, sigma Cn Xn plus 1, n equals 0 to infinity. We said that we will write k equal n plus 1, means that n equal k minus 1. What will we get here? The infinity is not affected here, the limit. C k minus 1 x power k. This one that is here, miss, n equals 0 here. And k is equal n plus 1. 0 plus 1 is what? 1. Okay, miss?
Okay.
Any questions? So now we will, instead of working with the old series, these are the new series that we will work with. This one and this one. So we need to substitute now, instead of the old series, we had already, miss, series 1 plus series 2 equal to 0. So what will we get now by substituting? Series 1 is 0 to infinity, k plus 2, k plus 1, c, k plus 2, x, k. And series 2 is sigma 1 to infinity, c, k minus 1, xk equal to 0. Right, miss?
Yes.
Okay. Now one of them starts at 0 and one of them starts at 1. So the one that starts at 0, how will we divide it?
We want to start at 1.
When we have sigma starts at 0, it is, we substitute this one at 0 plus, it will be in this form, right, miss? So what will we get now? The first series at k equals 0, what will we get, miss? 0 plus 2, 0 plus 1, so 2 c2 x power 0, which is 2 c2 plus sigma from 1 to infinity k plus 2 k plus 1 c k plus 2 xk, this one is series 1, plus series 2 sigma 1 to infinity 1 to infinity c k minus 1 x power k equal to 0. Now if you look at this one, miss, both starts at 1, both are power k. Are we able to put them inside the same series?
Yes.
Okay, miss, please write it down and put them in front inside the same series. Did we put them inside the same series, miss? Okay, what will we get now? 2c2 plus sigma from 1 to infinity x power k equal to 0. What will we put from the first one? It was k plus 2, k plus 1, c k plus 2, and from the second one we had c
K minus 1.
k minus 1. Okay, miss? Is it clear?
Yes.
Okay, we got a series equal to 0. It means that this one is 0 and this coefficient is 0. Do we agree?
Yes.
So we got here k plus 2 into k plus 1, ck plus 2 plus ck minus 1 equals 0, and 2c2 equal to 0. Can we write it as ck plus 2 equal minus 1 over k plus 2, k plus 1, ck minus 1, and c2 equal to 0? Can we write it in this way, miss?
Yes.
Bring minus ck minus 1 to the other side, it becomes minus, and divide by k plus 2, k plus 1. Is it clear?
Yes,
Is
doctor.
it clear, miss?
Yes.
Okay. Miss, remember, what do we have here? Second order, okay? So, second order ODE. What do we mean by it? It means that find pK in terms of what, miss? C0 and C0 is enough?
No, and another variable, C1.
And C1, okay? So if it's first order, all the other CKs will be in terms of C0. If it is second order, in terms of C0 and C1. If it's third order, C0, C1, C2, okay?
Okay.
Now we need to complete a table. Is it necessary to put a table? No need, miss. But if you, because if it's easier to identify it using a table, it's better. Now, miss, do I start with k equals 0? If I started with k equals 0, it will give me something wrong. C minus 1. It doesn't make sense. And already if I have k equals 0, C2 is already what, miss? 0. So I will not start with k equals 0. We will start with k equal 1, k equal 2, k equal 3, k equal 4, k equal 5, k equal 6. Okay? Miss, what I need from you to do is, this is the relation. Please find it at k equal 1. Substitute and give me the answer. At k equal 1, which C we will get?
T3.
Okay, so the left-hand side, we will get here C3. The right-hand side, substitute. Minus 1 over 3 times 2, right? C k minus 1. Right, miss? So we are substituting k equal 1. We will get this one. Do we agree? Do we agree, miss?
Yes.
So basically we got minus 1 over 6 C0. Is it accepted? Yes, we got it in terms of C0. Is it clear, miss?
Yes.
Yes. At k equal 2, what will happen? We will get C2 plus 2, which is 4, equal minus 1 over 4 times 3, minus 1, 4 times 3, C 2 minus 1, right, miss? No,
C1.
sorry, I put k equal 2, exactly. C2 minus 1. So what did we get here? Negative 1 over 12, C1. Is it accepted?
Yes.
What did we say? We want to find everything in terms of C0 and C1. Please, miss, go back to your recurrence relation and check our substitution. If everything is okay, we will continue, or I will give you time to find k equal 3 and k equal 4. So, Sultan Abdullah, let me just, okay. Miss, the A's, if your name starts with A, find C3, and if it doesn't start with A, find C4. I'll give you a couple of minutes and then we will discuss. Okay, Miss? Again, this is the relation ck plus 2 equal negative 1 over k plus 2, k plus 1, ck minus 1. We need the A's to start with k equal 3 and the rest to start with k equal 4. Any answer for k equal 3? Any answer, Miss? K equal 3. What will we get when k equal 3, Miss? C, 3 plus 2. Miss, at k equal 3, it means that instead of this, what will we put? 3. Instead of this k, we will remove the k's. And what do we put instead of it? 3. So what will we get? C5 equal this one times C2, right? And what's C2? What's C2, guys?
0.
So what will be the answer?
0.
So C5, we will substitute minus 1 over 5 times 4, C2, which is 0. And we will highlight the zeros in this. This is very important, okay? Ahmed, did we get the same answer? Miss, can we write our answers in the chat box if you are muted, Miss? Abdurrahman, what did we get? Okay, Abu Zaid and Ali?
Yes, Doctor, same answer.
Okay, perfect. Now, for those who found the second one, C6, Sultan, Johnny, Ismail, Noor, what did we get?
I got C0 over 180.
Okay, let me check. Shamus and Dilshad, what did we get? Let's try it, Miss, again.
I didn't solve it, Doctor.
Okay, so let's solve it together. We need to substitute k equal 4. So what will we get? K plus 2. C4, it will be what, Miss? C4 plus 2, it will be?
C6.
So here, basically, we have C6 equal. We will substitute 6 times 5. And here, what do we put? C4, right? K equal, let me just check it again. C4 minus 1, sorry. C4 minus 1 is C3. Johnny, you wrote it in this way?
Yes.
Okay. So minus 1 over 6, 5 times minus 1 over 6, which is 6 times 6 times 5, we will get? Miss, 6 times 5, 30 times 6, 180.
Okay.
Is it accepted?
Yes, because it's in C0.
It's in terms of C0. Miss, can now all of us find at a k equal 5?
Doctor, didn't you say we only needed three terms? 3 non-zero terms?
Yes, but I will find just at k equal 5.
So in
Because
the
if
exam,
you
you
look
could just...
here, the idea is that already we have C0. And I found at k equal 1 and at k equal 4, it's in terms of C0. But in terms of C1, I have only C1 and at k equal 2. So I need one more on C1, which is k equal 5.
So two
Did you
from
get it?
every. So
Yes,
two
so
from every.
yes, exactly.
Okay.
At k equal 5, we will get C7 equal -1 over 7 times 6, and here C4. What's C4, miss? C4 is -1 over 12, C1. So multiply now, 7 times 6, 42, 42 times 12. What's 42 times 12, miss?
504.
540 or 4?
4.
Okay. Now we will substitute here C8. It will be -1 over 8 times 7 multiplied by C5. And C5 again, it's what? What's C5, miss?
0.
It's 0. Any questions regarding the table, miss? Okay. What's the next step now? Miss, are we taking notes? We're taking notes, miss?
Yes, of course.
Done with the notes? Please let me know when I can move to another slide.
I'm done this, the other people.
Okay. The other is done. Please write in the chat box. So now the solution is y equals C0 plus C1x plus C2x squared plus C3x3 plus C4x. For how many should I write? The ones that I found in the table. I found till C8, right? Plus C5x5 plus C6x6 plus C7x7 plus C8x8 plus. First of all, I will get rid of the zeros. What are the zeros? C2 is 0, C5 and C8. So C2 is 0, C5 and C8. Okay, miss? The first step, are we okay with it?
Yes.
C0 plus C1x, we keep them the same. Now, plus C3x. C3x cubed. What was C3? C3 from the table, what was it, miss?
Negative C0 over 6.
So we will substitute it. Then, plus C4x4. X4, C4, it was negative C1 over 12. C6, X6, what was C6, miss? 1 over 180, right? Plus X6, C0 over 180, plus the last one, C7, it was 1 over 504, C1, and we put plus. The C0s, we will highlight them in a color, and the C1, we will highlight it in another color. We will collect the C0s together, the pink together, and the blue together. Can we, miss? So please take your notes, collect the C0 alone and the C1 alone. Okay, miss. Did we collect them together? So we will
Yes.
get, miss, y equals C0 into something plus C1 into something. C0, we will take 1 minus x cube, it was, right? Over 6. Then plus x6 over 180 plus, we put these 3 dots. C1 x minus x4 over 12 plus x7 over 504 plus these ones. This one is the blue part. And this one is our pink part. So basically here, what did we get, miss? We got it as C0 Y1 plus C1 Y2. Y1 is the pink part and Y2 is the blue part. So we got 2 independent series solutions. The first series solution is 1 minus x cubed over 6 plus x6 over 180 and so on. And the second is the blue part. Is it clear, miss? Is it clear?
Yes.
Yes, doctor.
Okay, miss. Miss, such an exercise in the exam, I expect that at least if it's out, okay, let me check. Suppose that we have on series around 8 points. I expect that minimum you will get 6 out of 8 because this is just a process. All what it needs is practice. The understanding about it, we got through it. Why do we need series solution and why do we have the right to apply series solution? But the application part is just process. Whatever we have, all what we are doing is substituting, getting recurrence relation, substituting again, and getting series solution. Is it clear, miss?
Doctor,
Yes.
I have a
Yes.
question. Could you go back
Yes,
to
Abu
the
Zaid.
yeah? Could you go back to the K1, K2, K3? Yes. That's can you. Why do we stop at K equals 6, not K equals 5?
No, miss, I did not stop at K equals 6. If I have a program, I will keep it in reality. These ones, we will not do them manually. We'll do them through program. We will just give the input as our recurrence relation and ask the program to solve for us the recurrence relation. So we can run it as much as we can. The more values that we run, the more accurate answer we get. But for me, because we are in the exam, 3 values related to C0 and 3 values related to C1, they are enough. I don't need more. If you want to continue, you can continue till 11, 12, 100. But miss, if we are saying, here, because we are solving it manually, but suppose that you have an engineering problem and you are finding the series solution, of course, you will not just find the first 5 terms. You need to run the program and give it, let's say, K between 1 and 1,000 or 2,000. It depends on the program. How much time does it need to give you 1,000 values, for example?
Okay.
Did I answer your question?
Yes, yes.
Okay, miss, here we have an example. Just write this one, miss, because we'll solve it. Already it's already solved here, but we'll solve it in detail. Let me check. Okay, so I will solve this example. We will discuss. Oh, okay, perfect. This example, it has a new idea. Then let me check. Okay, this example, we will discuss it without solving it. And I will give you to solve, maybe we can solve this one as group, but let's now solve this. So just write the differential equation in order to start, and I expect that all of us are able to write y as a series, y prime as a series, and y double prime as a series. So did we write the question, miss? What was the equation, miss, that we want to solve? Y double prime, x squared plus 1. We have this one. We will take y equal sigma from 0 to infinity Cn xn. We need here y prime because we have it. Sigma from 1 to infinity n Cn xn minus 1, and y double prime from 2 to infinity n into n minus 1 Cn x n minus 2. The first step, is it clear for all of us? So let's divide it as steps. This is step number 1. Are we okay with it, miss?
Yes.
Step number 2, we need to substitute where? Step number 2, substitute in
the ODE.
the ODE. Miss, now the thing here is that if we have something, it's better to expand it. So we will get here x squared y double prime plus y double prime plus xy prime minus y equal to 0. X squared y double prime sigma from 2 to infinity n into n minus 1 Cn xn minus 2 and 2. What will we get, miss? N. Right, miss? Right?
Yeah.
Okay. So how many series here we are getting? We will get 4 series, okay? Y double prime is 2 to infinity n into n minus 1 Cn x n minus 2 plus xy prime. It's from 1 to infinity. Xy prime is n, Cn xn minus 1. And x outside, what will we get here? Xn. Then the last one, minus sigma 0 to infinity Cn xn equal to 0. Questions, miss?
Both of them have the same xn. Can we add them together?
But not now, not at this moment. Where's our problem? The problem is not in the xn. Where's the problem? The problem here in the starting value.
Oh yeah, okay.
So these are xn, whereas this one is xn minus 2. So now let's put all of them power k instead of n and n minus 2. I will keep the series in front of you and put all of them power k. So here we have 4 series. We have 4 series here. Series 1, it is sigma 2 to infinity n into n minus 1 Cn xn. Here we will put k equal n. Is it affected? Is series 1 affected in any way, miss?
No, just switch n to k.
Exactly. Now, series 2, This is series 2. And what else do we have? Series 3 and series 4. This is series 3. And series 4 is here. So this is series 4. This is series 1. We said K equal to N. So is it affected, miss? What will be the new one? Sigma 2 to infinity, K minus 1, CK, XK. Do we agree? Do we agree, miss?
Yes.
Now this is series number 2. What should we put here? K equal N minus 2. So N is equal K plus 2. What will we get now? Infinity, but this 2 that is here, it will be 2 minus 2. And it is K plus 2, K plus 1. And here, what will we put? C, K plus 2, and here, XK. Do we agree that we will get this one, miss?
Yes.
Okay. Now, series number 3, miss.
It's the same
Again,
thing.
K equal N, it's not affected, so this one is equal sigma 1 to infinity, K, CK, XK. Series number 4 as well, K equal N. This one is not affected, so sigma 0 to infinity, CK, XK. Any questions?
No, doctor.
Now we had series 1 plus series 2 plus series 3 minus series 4 equal to 0. Right, miss? We
Yes.
have these ones, right, miss?
We need to change them to start at 2.
Yeah, but at the first time I need to write it, miss. So I need to help me in writing it. Miss, can you take screenshot of the first one so that you give me the answer of it? Did we take a screenshot of the first series?
Yes.
Second series?
Yeah, I already have them in the book.
Okay. Third series? And fourth series. Now I need to add them. 1. What's series
Okay.
number 1?
2 to infinity. K times K minus 1. CK, KX. XK.
X power. Okay.
Okay.
Series 2?
0 to infinity. K plus 2 times K plus 1. CK plus 2. XK.
Okay. This is minus, right? We said no plus. Okay. Series 3?
1 to infinity. CK, XK.
Series
And then
4?
negative 0 to infinity. CK, XK.
Perfect. Okay, miss. We have 2. Miss, look what we have. We have 2. We have 0. We have 1. We have 0. So all of them, they should start at 2, right? The 0 that is here and the 0 that is here, we will combine them together, have them at 0, at 1, and then sigma from 2 to infinity. This one, we will have it first at 1 plus sigma from 2 to infinity. Okay, miss? Now, what I need from you to do is that, okay, miss, it's okay. We can do each one alone. Now, the first one, we will keep it the same, right? So again, miss, series 1, series 2, series 3, series 4, all of them, we should start them at 2. So this series now, we will write it.
Doctor,
Yes, miss?
I think there's a K missing in series 3.
I will check it. So where is the missing thing that we wrote? C3, it contains a K.
I think it's supposed to be K times CK because there was an N before.
Yes, K. Series 3, it's K. Yeah, I copied it. Okay, so this is series 3. Just I need to put K, CK. Okay, miss? Now, series 1, series 2. This one is series 2. We need to write it at K equals 0 plus at K equal 1, right? Plus sigma from 2 to infinity, which is K plus 2, K plus 1, K plus 2, and here what do we have? Xk. At K equals 0, what will we get, miss? 2 C2. At K equal 1, 6 C3 times what, miss? Times X. So this one, at K equals 0, we substituted, and this one, at K equal 1. Please check, miss, if everything is okay regarding this one. Is it clear? Is it clear, miss?
Yes.
Now we need series 3. So this one, we will take it. So this one is series 3. We will write it equal at K equal 1 plus summation from 2 to infinity K, Ck, Xk. At K equal 1, 1 times C1, C1. X power 1 is C1X. Do we agree? Do we agree, guys?
Yes.
Still, what do we have? We need the last series now, right? So series 4, it's equal at 0 plus at 1 plus sigma from 2 to infinity Ck, Xk. At 0, C0. At 1, C1, X. Is it clear, miss? Is it clear?
Yes, doctor.
Doctor,
Okay.
why didn't you do negative? Because
Yeah, I will.
after
I
you
will.
do. Yeah, okay.
I will. Okay. So again, 1 plus 2 plus 3 minus 4 equal to 0. Now we need to substitute. 1, we will copy it the same, which is, because we don't have problem in it. This is our 1. We will copy it the same. So this is 1. Okay, miss? 2. What was 2? 2c2 plus 6c3x. So plus 2c2 plus 6c3x plus sigma from 2 to infinity k plus 2 k plus 1 c k plus 2 x power k. Okay, miss? Questions? Plus 3, it was c1x plus sigma from 2 to infinity k ck xk minus c4 minus 4. Minus 4, it means minus c0 minus c1x minus sigma from 2 to infinity ck xk equal to 0. Any questions till now, miss? Any questions?
No.
What do we have here? C1x and negative C1x. They are cancelled together. Okay, miss? We are left with 2C2 and minus C0. We will write this one alone. 2C2 minus C0 plus summation from k equal to infinity x power k equal to 0. We will write everything that we have. Okay? And what else we have also, miss? We have 63x. So I should write it, right, miss? So we will write plus 6 C3x. Now this series. The first one, what do we have from it? K into k minus 1 ck. Right? It was ck or ck plus 2, miss? Okay, ck, yes. Okay. The second one, we have k plus 2, k plus 1. So plus k plus 2, k plus 1, ck plus 2. The third one plus k ck. And the fourth one is minus ck. So plus k ck minus ck x power k equal to 0. Right, miss? Is it clear? So we just copied them. Any questions? Do we have any questions, miss?
No, but can you just give us some time to copy it?
Of course,
And
miss. I will give you time also to think about it. What are the next steps? We have now a series equal to 0. This is the constant, right? This is the coefficient of x. And this one is the coefficient of x power k. So each of these colors, it should be equal 0. Do we agree?
Yes.
Okay. So from the first one, we will get 2C2 minus C0 equals 0. What can we deduce? We write the large in terms of the small. And from the second one, we'll get 6C3 equals 0. It means that C3 is equal to 0. Now, this recurrence relation, we will copy it again. This one that is here. We will copy it again. How I can get the white color, miss? Okay. So the coefficient is 0 now. Okay? Okay, miss?
Doctor, I just have a small question.
Yeah.
For slide 47, why didn't we take C2 as 0 and C0 as 0 and C3 as 0?
Miss, because the constant coefficient is 0. What's the constant here?
Oh,
If the
okay.
constant
So
is
choose,
A plus B plus C plus D, it means that all as a whole is 0, but it doesn't mean that A alone is 0 and B alone is 0 and C alone is 0.
Okay.
Okay. Now, can we simplify this one, miss? Let's simplify it. K square minus K EK. K plus 2, I will keep it the same at this moment, miss, okay? Because we have it only alone, but the other ones, we need to add them up. Or simply, miss, what we are doing now is that we have K plus 2 K plus 1, CK plus 2, plus CK. What's left for CK? K square minus K from here. From here we have plus K, and from here what do we have? Minus 1. Does it make sense? Is it clear, miss?
Yes.
Is it clear? Okay. What will we get? Write it down. Minus K and K are cancelled together, right? What will we get now?
CK, K squared minus CK.
So K plus 2 into K plus 1, CK plus 2, and plus K square minus 1, CK equals 0. Again, miss, we need to write CK plus 2 in terms of the other. So minus K square minus 1 CK over K plus 1 into K plus 2. This answer is accepted, but are we able to simplify a little bit? Can we remove these two terms together? Is it okay, miss? Is it
Just
clear?
give us, yeah, just give us 1 minute.
Yes. Okay, guys, so what will we get now? So now, do we agree that we will get these ones? C2 is half C0, and this one minus into K minus 1 is 1 minus K over K plus 2 CK. Now we need to start taking values, miss, right? So we need now to complete our table. We will take here values for K. And here we will have DC. Miss, we have this one, CK plus 2. Do we take K equals 0? If we took K equals 0, then we will get C2. We have it. Do we take K equal 1? We have
No.
C3. So we will start with K equal 2,
2.
3, 4, 5. So at K equal 2, what will we get? C4. And at K equal 3, we will get C5. At K equal 4, we will get C6. And at K equal 5, we will get C7. Right, miss? Is it clear, miss?
Yes.
Okay. Substitute, what will we get? K equal 2, it means that 1 minus 2, which is negative 1 over 4. And here, C2. What's C2, miss? What's C2?
We already have it as C0 over 2.
Exactly. Again, all our answers should be in terms of C0 and C1. Now, C5. So 1 minus 3 is negative 2 over 5. C3. What's C3? 0. I will
Doctor,
highlight this one as 0.
for C4, shouldn't it be negative? Negative 1 over 8?
C4?
Yeah, for C4. K equals 2.
It's okay. It's negative, yeah, because it's
Yeah, positive C0.
yeah, it's okay. Thank you, Johnny. At K equal 4, what will we get? Negative 3 over 6 and C4. And what's C4, miss? 3 over 48. 3 over 48. Okay, I will keep it as 3 over 48 at this moment. And what will I put here? C0. Okay, miss? C7. 1 minus 5 minus 4 over 7. C5. And C5, miss, is equal to what? Equal to 0. Do we have any questions so far?
No.
Miss, we did not get any C1. What should we do?
Do we need to continue?
Miss, even if I continued, try C8. Okay, C8 at K equals 6, it will be in terms of what? C6, and C6 is in terms of C0. So here, either I'm getting in terms of C0 or I'm getting 0. Will I get C1?
No.
No. So it's okay to stop here. And now we will write the solution in this way. Y equals C0 plus C1x plus C2x squared plus C3x cubed plus C4x4 plus C5x7 plus C6x6 plus, what are the zeros, miss? C3 is 0, right? And C5 is 0, and this one, it was 0. And this one, C1x, I will keep it alone because I have it only. And C0. One, C2 it was? What was C2, miss?
Half C0.
Okay, so x squared over 2. And what was C4? Minus over 8. And C6, it was plus 3 over 48. So, miss, what are the series that we got? We got this series. And this x, it can be considered as a series as well. X plus 0 plus 0 plus 0 plus 0. Okay, miss? So the importance of this question, the process is the same. We did like it. But the importance of it is that it's okay to get none of our constants in terms of C0. I will still have C0 into 1. It's also okay to get none of the constants in terms of C1. I will get C1 times X. So X is a solution and the other solution is 0. Okay, miss? Is it clear?
Yes.
So look here, miss. This is the first series solution. And this is the second one. Okay, miss? So C0 into Y1 plus C2 into Y2. Any questions, miss? Do we have questions?
No.
Now, this one, we will do the same for it. Remember, miss, this one, we will write it y double prime minus y minus xy. So here we will get 3 series. We will substitute. I will start with the recurrence relation in this way, miss. What's the difference between this recurrence relation and the previous question? The previous one, it was, miss, ck plus 2 equals ck into something, right? Here, what do we have, miss? Look at it, miss. What do we have here? It depends on 2 things at the same time. So look at the table when we fill it, miss. At k equal 0, what will we get? C2 equal, we cannot take k equal 0, miss, here. At k equal 1, what will we get? C3 equal C1 plus C0 over k equal 1. It means that 2 times 3. So we got C1 plus C0 over 6. So C3 depends on what, miss? On
C1 and
C0
C0.
and C1. Let's try k equal 2. We will get C4 is equal to C2 plus C1 over 3 times 4, which is 12. And again, C2, I should be putting for you here C2 equal to what? C2 is equal to what? Half C0. So we will write here 0.5 C0 plus C1 over 12. So each term is dependent on what? On C0 and C1. Here it's already completed. Now we are discussing, I'm not solving it. So look here, miss. C2, it depends on C0. C3, we are writing it not in the way that I want. Okay, so I will remove this one. Okay, now let's find it at k equal 3, miss. At k equal 3, what will we get, miss? C 5 equal, at k equal 3, miss, C3 plus C2, right? So C3 plus C2 over k equal 3, we will get 4 times 5, which is 20. And C3 is equal to what, miss? C1 plus C0 over 6, and C2 is C0 over 2, and we have over 20. Is it clear, miss? Is it clear?
Yes.
Yes.
Okay, continue. What will we get, miss? We need to write it in terms of C1 and C0 in a better form. So we will get C1 over 120.
So C0 over 120.
Here C0 over 6 and C0 over 2. So we'll get C0 over 6 plus 3. It means that for C0 over 6, which is 2C0 over 3. So 2C0 over 3 times 20, which is 60, which is C1 over 120 plus C0 over 30.
Oh, yes, yes.
Means that we need just, it's a matter of simplification. Now, the main thing here is to write it. How will we write it, miss? We need to write the solution. Now, in this case, we don't need to find lots of values. 3 values for k, they are enough. We will get C0 plus C1x plus C2x squared plus C3x3 plus C4x4 plus so on. Now, C0 and C1, I will keep them the same, right? C0 plus C1x, C2x squared is C0 over 2x squared, right, miss? C3, what was it? C1 plus C0 over 6. So we will write here plus C1 plus C0 over 6, x3, x4. At 4, C4, what did we get it? C0 over 20.
C0.
C0 over 24 plus C1 over 12. And so on. Our aim is, again, remember that our aim is to write y equal constants times y equal something, function times C0 plus function times C1. So we need to collect these C0s. And then we will collect what, miss? The C1s. Okay?
Yes.
So our aim is to write it as C0 into something plus C1 into something. C0. From the first one, what can we get? 1.
1 plus half
Plus x
squared.
squared over 2. This one we will get 1 over 6 x cubed. So plus x cubed over 6. And from this one over x4 over 24. And we will put pluses. Now, C1 from here, we will get x first. From the second, we will get x cubed over 6. From the third, we will get x4 over 12. And we will put. So this one is our y1. And this one, it will be our y2. Is it clear, miss? Is this clear?
Yes, doctor.
Yes.
Guys, do we have questions?
No.
Okay. Can we take this one, y double prime plus x square y? I will just screenshot it, send it in the chat, and I will send you to breakout rooms to start with this one to make sure that everything is okay. And then we will discuss again. So I will just create the rooms. I sent it in the chat, so please start with it. And then we will discuss. Hello, guys. So how did we start, Miss? Which group would like to start sharing? Guys, you're hearing me?
Yes, doctor.
Okay, so how were the steps? Did you go smoothly on the steps, or you faced any certain problem?
It was easy.
It was
But we
easy.
reached
The other groups, yes, Johnny?
we reached until the k equals 2, k equals 3, k equals 4.
Mm. Okay, perfect. Dilshad, Ahmad, Sultan, Ismail, Ali. What's our feedback?
Same group.
Yeah, at the same step, we are converting N to K.
Oh, okay, Miss. So this was all about the series solution. Let's go back to our main objectives. The main objectives, it was to use pair series to find the general solution of a linear ODE. And as we said before, that this general solution, we are finding it for linear ODE, where x equals 0 is an ordinary point. So we covered the pair series, how we add ordinary and singular points, and the method of pair series solution. Hopefully, Miss, so we're done by this. We are done with chapter 6. Hopefully next week we will start with Laplace transform. Now, if you think about Laplace transform, that if we miss the first lecture, we will not be able to understand any of the lectures. All lectures will be dependent on each other. So the first lecture, it will be how do we find the Laplace, and we will understand the inverse Laplace from it, and then we will apply it to differential equations. Any questions for today, Miss?
No,
Do we
doctor,
have
thank you.
questions? Okay, Miss.
No, thank you, doctor.
Have a great day, and if you finished your classes today, have a great weekend, and we'll see you hopefully next week. I will stop recording now. Bye, Miss.
Doctor, for the exam too, can I see the feedback or?
Yes, of course. I will send you other timing on Monday.
Okay, thank you.
Okay, Miss. See you.
Have a nice day.
You too. Bye.